This video is for the solving quadratics using square roots notes. So we've got several different types here. We've got 1-step, 2-step, and then 3-step equations. Okay. All right, so the first one, a 1-step example. Solve the following quadratic using square roots. So what we're going to do is we're going to take the square root of both sides. So we're going to square root x squared, and that's equal to the square root of 44. So these are just examples when you have a quadratic that's set up like this, or it could even be x squared minus 44 equals 0, and you can move just the constant to the other side of the equation. So when we do this, when we square root an x squared, the square root and the exponent, these cancel each other, so we're left with x. Now we can break down 44, and so this is where those simplifying radicals comes in handy. So if we do 44 divided by 2, so we've got 2 times, we can divide 22 by 2, and then we're left with an 11, and 11 is prime. So the square root of 44 is the same as, remember we can group things in groups of 2, is the same thing as the square root of 2 squared times the square root of an 11. So again, the square root cancels that exponent, and so I'm left with positive negative 2 times the square root of 11. Now sometimes you have nice pretty ones like we have here. So if we square both sides here, the square root of x squared is x, and then the square root of 64 is just positive negative 8. And so again, sometimes you have nice pretty ones that are perfect squares that this works really well on. Other times, so if we square root x squared, we get an x. And then 21, if we try to break 21 down, 21 divided by 3, it's just 3 times 7. Those are both prime numbers. That's the prime factorization. There's nothing to break down. So this one would just be positive negative square root of 21. And then x squared equals 54. So if we square root the x squared, we get an x. 54, let's see if we can break that one down. So 54 divided by 2 is 27. So we've got 2 times 27. We can divide by 3. And we get a 9, and then we know 9 breaks down into 3 times 3. So I've got a group of 2 here. So this one would be, what I'm going to do, I'm going to square 3 squared, square root, times, and then I'm going to multiply the 2 and the 3 together, times the square root of 6. That just kind of keeps everything nice and neat for me. So x equals, so the square root cancels the exponent, and then we just tack the square root of 6 onto the end. All right, so now we have a 2-step. So we can see here that we've got an x squared and then we've got 2 constants. So what we want to do is we want to rearrange the equation so that the constant is on the right side of the equation. So I'm going to subtract 3 from both sides. X squared equals, so these will cancel, 7 minus 3 gives me a 4, and then we square both sides. So square root of x squared, square root of 4, square root cancels, so x equals positive negative, the square root of 4 is 2. Okay. Next we have one where our a value is not 1. So we have 4x squared equals 4. So the first thing we want to do is simplify it so that a equals 1. So 4x squared equals 4. I can divide both sides by 4. So when we're working with equations, as long as we do it to both sides, we're good. So these 4's will cancel, and I'm left with x squared. And then 4 over 4 simplifies to 1. So what I've got here is x squared equals 1. So I can square root both sides. So the square root and the square cancel. And the square root of 1 is just 1. So positive negative 1. All right, now a 3-step one. 9x squared minus 1 equals 3. Rearrange the equation so the constant's on the right. So this one I'm going to add the 1 to both sides. So I've got 9x squared equals 4. Now I'm going to simplify the equation so that a equals 1. So I need to divide both sides by 9 here. So I'm going to write this over here. 9x squared equals 4. So I'm going to divide this side by 9 and this side by 9. So these 9's will cancel, and I'm left with x squared equals 4 over 9. And then we take the square root of both sides. So the square root of x squared equals, the square root of 4 over 9. Now, when we square root a fraction like this, so we know this is going to cancel out. I can break this down, and I can square root the numerator, and I can square root the denominator. So x equals positive, negative. The square root of 4 is 2. The square root of 9 is 3. So one of those little fraction radical rules that if you square root a fraction, you can square root the numerator and the denominator separately. So 2x squared plus 3 equals 5. So we're going to subtract 3 from both sides. So I'd be left with 2x squared. This is going to cancel. 5 minus 3 equals 2. Then I can simplify and divide both sides by 2. This cancels, and I'm left with x squared equals 1. And so if I square root both sides, what I'm left with is x squared equals positive negative 1. So it's just a matter of rearranging pieces. So on number 2, I'm going to add 3 to both sides. So here I'm going to have 2x squared. This will cancel. 13 plus 3 is 16. Then I'm going to divide both sides by 2. So this cancels. 16 divided by 2 is 8. We're going to square root both sides. So these will cancel each other. So the square root of 8, 8 is just 2 times 2 times 2. So I can do the square root of 2 squared times the square root of 2. These will cancel. So positive negative 2 times the square root of 2. It's just simplifying radicals. And then on this last one, I'm going to subtract 3 from both sides. So I'll have 3x squared. This cancels. 12 minus 3 will give me a 9. I can divide both sides by 3. So this will cancel for me. 9 divided by 3 is 3. If I square root both sides, x squared equals the square root of 3. These will cancel. Square root of 3 won't simplify any further, so x equals positive negative square root of 3.